So, tell me something funny before we begin. I want to hear something funny. Hi, YouTube. How's it going? No one's online. There's no one watching. No one's online. Chalo. Tell me a good joke before we begin. Let's have a laugh before we start. Who knows a good joke? Mesam, Haya, Miral, Rahim. Anyone? Hey, one person's watching. Let me check the audio quality. YouTube, is the audio quality fine? Just do me a dog water. Dog water. Yeah. I have a cousin who thought very young at that time. Thought he's much older now. He thought one particular word, like the, was also a swear word. So he would call everyone that, and he'd say like heron, right? Like deer in Urdu is called heron, and he would call everyone heron, and he was just really funny. He had like pure rage, and he would call like heron, and it's like it's funny. You had to be there. Oh well, dog water beats it though. That's actually not a bad insult. Dog water. Like if you think about it, you're dog water. Okay. Hey, first like for the day. Shall we start? No one's telling me. Okay, all right. Haya said anything funny. Hello, Rida. Guys, we're trying to say a funny joke or something funny before we start. Something funny. Can we do that or no? Can we do that? I'm waiting. Okay, but that's not funny. That's just, I mean, you announced it. Oh, you're saying it to the panelist. Okay. Okay, I won't say it to anyone. You should start with don't say it to anyone, then say it, because I might have said it before we began. Okay, let's try this. Let's see if we can do this particular question. I'm gonna try my best to confuse you. And I guess people like being confused because they, or probably not. Let me get some aid. Here's a line. I'm going to draw a polymer, which you guys have to tell me what it is. I think I'm drawing a big tell me something funny and try to copy this. Let's see if we can figure out what this molecule is. All right, I think we're almost done. I don't have any more space. It might be challenging. Sir Bilal, not today. Can you not hear me? Rahim, can you not recognize my voice? I think we'll have a very poor attendance on YouTube today. Yeah, Sir Bilal isn't here today. Got it. Oh, Masam, that's not sad. That just happens. Just don't let it, But I'm sure you know. Don't let it bring you down, and just do it. Just continue with your life. So what? And yeah. Yeah, sure. Are you guys missing Sir Bilal? What is the monomers? What are the monomers over here? What are the monomers over here? Are you guys done? So I can try drawing it. Yeah, no one's watching. Oh, yeah. Do you guys need more time? Why you guys not saying me anything? 1 minute, one more minute. I don't like this pink color. All right. Draw the monomer. Highlight what kind of polymerization this is. Find the monomers, sorry. Almost done. Nice. Let me know when you guys are done. No one has told me anything funny either. Abdul Rahman, Taimur, how are you? How come I see most people like at odd hours? Why is that the case? Abdul Rahman, I'm just curious. Why don't I see you more regularly? Oh, you watch it on YouTube. Okay. I'll say hi when you watch it on YouTube. Well, I don't know, because I'm just looking at a black screen. If you guys don't say hi or anything, it just becomes very dull. And you can probably tell by now, I get in a nice mood when people are nice to me. Like, that sounds sad when I say it like that. But like, if you're nice to someone, they get in a good mood. If you smile with someone, they'll smile back. If you're angry at someone, they'll be angry back. If you're silent to someone, they'll be silent back. You don't want your teacher to be silent towards you. Just done? Okay. Should I give 1 more minute to people or should I draw it? Okay, a bit confused. That's good. That's good. Okay. What kind of polymerization in it? How many of you think it's addition polymerization? Okay. It's addition polymerization? Okay. Because of the double bond? Because the double bond is present? Is that why you guys think it's addition polymerization? Yeah, right? And that makes sense. If I say you're not in the right thinking process, because when you have a monomer, let's say ethene, and if it polymerizes because of the double bond, right? This is polymerizing because of the double bond. The double bond goes away when it polymerizes. So in the polymer, you never see the double bond show up. Womp womp. What happened here? So there's a double bond over here. That means it's just part of the molecule and it never polymerized through the double bond. So it's not very likely addition polymerization. Does that make sense? It's not addition polymerization. I placed the double bond as a bait. I am trying to confuse you. Are you guys fell into my trap? Is that mean of me? It probably is, but hey, you learn from your mistakes. You didn't understand? The idea is if you have a double bond and that's undergoing polymerization, so you've realized different parts of the molecule undergo polymerization. Either it's the ester part, right, like how you see it over here, or the double bond. If the double bond undergoes polymerization, so the double bond goes away. So in the final molecule, this would be the molecule. This would be the polymer. So there's no double bond over here. If you see, this is the product. You don't see the double bond over here. Do you see it? Do you see any double bond over here? This was the starting point. There's no double bond over here. So in the product, you don't see polymerization, like that sort of thing. So that's the idea. This double bond would have gone away. It would have opened up here if it was addition polymerization. It's not addition polymerization. Or, I mean, technically it could be still, but it's not, because we see ester links everywhere, don't we? We're seeing ester links. Masam keeps saying nope. What does that mean? I'll remove this line because I don't need it anymore. Oh, I asked a question you're answering? Okay. Do you understand now? Does this make sense? How many of you still think it might be addition polymerization? Okay. I guess no answer means no. Take it. It's not addition polymerization. The double bond was there to confuse you. And let's see why it's exactly not addition polymerization. Well, we saw why exactly it's not. And what's the steps I highlighted for you guys? I said break. Step 1 is identify your ester linkage and break it there. Right? And this is not complete on the left hand side, but looking at the molecule, I'm pretty sure the link was there. And if you notice, this is the molecule repeating itself. It's the same molecule repeating itself, right? So I'll try redrawing this. Let me try redrawing this molecule. It's an O. I could just copy it, but I'm just doing it so you guys get some practice out of me looking at me draw. Okay, I drew my repeat unit. And what's left is I have an incomplete repeat unit, like, right? Or well, repeat unit is fine. The monomer is incomplete. How do I figure out the monomer? Now, this looks like the acid part to me, and this looks like the alcohol part to me. So it's one of those molecules where both alcohol and acid functional groups are there. And I'll try to complete it by putting an OH in front of it and an H in front of it. Now, this is no different from the examples we did earlier. This part is overly complicated. I gave it to you just to confuse you, and you just had to more or less ignore it. Remember, we put like boxes in front of it, rectangular boxes, and we color them, right? I've shown you that. Salute if you guys agree. Don't do anything if you guys don't agree, or just sad face without the salute. . 。  . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay, okay, 2 salutes. Miral and Haya get it. What about everyone else? My son gets it. Rita, Ramis, Rahim, Abdul Rahman. What say you? Rita gets it. 4 agrees. 4 agrees. Is this easy? Is this easy now? Is this easy? Sort of? Yeah? Okay. So let's try what? Sorry, I should have warned. Let's start with polyesters, then move on to other. Let's take a look at this. I should have gone over a few things. What is meant by the term condensation reaction? Who can talk about this? Who can talk about this? What is meant by a condensation reaction? Let me show the whole question. It means 2 different products are formed, right? And that's what it's trying to highlight. Condensation, you can say water is formed, but it's more apt to say 2 different products are formed, because we always see water, but it sometimes might be, yeah, well, you don't have to say acid and alcohol, because we'll see in a bit there might be another type of polymerization where the alcohol is not present. It's just the acid with something else, but the other thing reacts exactly like the alcohol, right? So it means, it's just trying to say what is meant by the term condensation reaction. It means multiple or more than, or like 2 molecules are formed. Should I say multiple or 2? Multiple molecules are formed. Actually, I think it's apt to say 2 different molecules are formed. But we're not gonna focus on this right now. We're gonna focus on the next part. There's a better way of answering this. We'll get to it. Okay. But let's try B. Look at B. Look at how they're showing us the question. Draw the structures of the 2 monomers used to produce this polymer. How do we do this? What's step 1? What's step 2? What's step 3? Did I make you guys write down steps for the reaction? I did, right? I asked everyone to write down steps. Yes. Just do the steps, blindly do the steps, and you'll find it 10 times easier. 10 times. Ten times easier. Not one person has said hi to me on YouTube today. I guess no one's there. No one's watching right now. Wow, okay. ये भी सही है. Mondays. Why is no one watching today? Masam came and said hi. Okay. ठीक है. Do you guys have an answer? Is this ready? Is this done? No one's saying anything? Again. You know, I did say I get slightly upset when no one says yes or no. I guess, you guess, you're guessing you're done. Okay. Done with this question? Shall I do it? Okay. So how I do this is I look at the question and I see my ester linkages are, this is my ester, this kind of looks like my ester, this looks like my ester, this looks like my ester, this probably looks like my ester. So I'll start cutting it here. Tuck, tuck, tuck. Well, yeah. And this probably looks like my ester as well, because if I take a closer look, now these are exactly the same, whereas these two are exactly the same. So they look like my two alcohols and these two look like my acids, right? Is that true? Does that make sense? Let me take gray. Oh, oh. That's the first one I'm trying to draw, right? And I'll also color the inside of it. And I'll draw the other molecule as well. I'll also do it in gray because I'm trying to mimic that. I can also do it just as neatly without using colors. Right, that's what I have. This molecule has been drawn here, redrawn over here. This molecule has redrawn over here. What is this functional group? Maybe this is difficult for people, but this is more easily identifiable. This has to be an acid. So I'll put an acid functional group in front of it. So over here it's an acid, over here it's an acid, right? Like the half of the acid functional group was already there. I just put an OH over here, right? And is my monomer complete? Well, one of them, for sure. And now I'm putting my H over here because this has to be the alcohol, and it lost an H, and I put it that here. So these two are my monomers that made the polymer drawn above. Does this make sense? How many of you get it? Salute, 7-star salute if you guys get it. And was this easy? Miral gets it. Miral gets it. Masam gets it. Rida gets it. Way easier than it looked? Yes, if you say it's way easier than it looked, you absolutely got it. You just, it's a joke once you get it. Like, it's not even chemistry, it's just Lego pieces. That's the best way I can describe it. It's stupid. Amna, hi, how are you? Welcome. Take care. Okay, let me talk about something. I'm going to the black screen now. I'll try warning you. So when you have esters, you have a monomer, you have monomers, either it could be one monomer or two monomers. I'll put an S in bracket that it could be one monomer or two monomers, right? Like monomers or monomer, right? They will turn into polymers, they turn into polymers. Now I shall remove this arrow because I don't want a straight arrow, I want a curved arrow. They turn into polymers. This process is known as condensation polymerization. I'll just write down condensation. This is condensation. Yes, you guys agree? You guys know this? And maybe just for extra kicks, I'll also write plus H2O, depending on how many react, but there will be not just one H2O, many H2Os depending on how many monomers react. This process is called condensation or condensation polymerization, right? You guys already know this. But the reverse process has also a name. And it's not something as straightforward as depolymerization. Amna, we're doing polymerization. We're doing questions on polymerization. The reverse process is not as simple as no, not cracking. And that would be logical. I wouldn't want to disagree, but it's not cracking. It should be. But we don't need to know how it works or anything, just the name of it. Now, there's a special name for a reaction where water is used to break things up. So if you think about it, polymers that are formed through condensation, when you break them down into monomers, you add water to them because this water is not actually present when the polymers are in front of you, right? So if you had the polyester, the parachute ka kapda in front of you, there's no water on it. Yes, Miral already knows what it's called. So it's because you're using water molecules to break it down. That process is known as hydrolysis. And you'll see that thrown a lot. And just know what they're trying to say. The hydrolysis of a polymer is just getting the monomers back, which you did so many times on Saturday and just today even twice, right? The process would be the hydrolysis of a polymer. Now, it's not true for addition polymerization, but they don't really ask you these things, but they'll just say the word hydrolysis a lot, right? So don't get confused. It's kind of like saying, oh, iron oxide was reduced in, if you know what reduced means, you know iron oxide was definitely reduced. And if you know what hydrolysis means, it's just a breaking down of something using water. So technically, condensation polymerization is going to a monomer, turning into monomers is hydrolysis. Does that make sense? Salute if you guys agree. Unsalute or like just show me the face if you guys disagree. Haya gets it. Miral got it. Masam gets it. Okay. PP get it. Fancy word, scary word. It's just is what it is. Actually, you could also call deesterification hydrolysis as well, because technically we're going back and it's deesterification. My first dislike. Wow. Okay. I'll survive. Stiff upper lip. Right? Deesterification is also called hydrolysis of esters. Now I'm going to a bright screen, so beware. Let's try doing a question. Here, do it. And let the world see you do it. 1 mark question. Partial structure of a condensation polymer is shown. They're telling you it's condensation polymer. Draw the structure of the monomer used to make this polymer. Three people watching now? No one's saying hi though. Hi, YouTube. No one wants to say. 5 people watching? I guess one's me. You guys don't leave any comments behind. I'm kind of, maybe it's... Hydrolysis is also known as deesterification. Deesterification is just about esters. Hydrolysis could be any reaction where water is used to break anything up. So, but we haven't really seen anything that has water molecules breaking up a molecule, right? So for us, it's just this example. But hydrolysis, you see a slightly more reactions in A levels. And if you do a degree in chemistry, hydrolysis would be a term you'd be throwing around a lot. But deesterification is a form of hydrolysis. You can argue that. Does that make sense, Masam? Hi, Rahim. Hi, Mohammed Shahir. How are you, Shahir? Yeah. So deesterification will always be a hydrolysis reaction. You can correctly assume and say that. Is this done? Can we get 20 likes today? No. Can we get 95 likes today? Done? It's pretty easy. It's pretty easy, pretty easy. You cut it over here where the ester link is, and you realize these two monomers are exactly identical. And you try drawing it again, and I do. This is the molecule I'm trying to draw. Why can't I draw it in a straight line? Now it's curved up, but I'll just flatten it out so it's easier to understand, but I can also make it like that if I want to. I actually would have, because it looks nicer that way. And here's my OH in front of the acid, my H in front of the... And we've seen this molecule. This is the first molecule we did when we were doing the... We've done this. We polymerized this on Saturday. Then we took this molecule and hydrolyzed it. Hydrolyzed it. Yeah, I think that's correctly. I'm saying it correctly. Hydrolyzed it, right? Does that make sense? We did this exact same molecule. Is this easy now? Is this easy? Show me that it's easy by spamming the... Can we get a new emoticon today? The nail polish, like putting nail polish on your nails emoji. Use that. I think, what's the shortcut for getting emoticons? Yeah, that one. Nassim gets it, Miral gets it. The nail polish emoji, people. You guys get it? I get it, I get it, I get it. I think Haya's struggling to find the emoji. Isn't that true, Haya? And Rida, what about you? Am I gonna get the... she got it. Rida, what about you? And who else do we have? Other Hanan. Other people aren't talking to me, so I won't talk to them. If you ask a question, I'm not gonna answer, guys. I swear it. If you guys ask a question, I'm not gonna answer. Okay, easy. Okay, let's talk about something else. Now, polyesters. Polyester is, you saw what the molecule is like, and you can make all different kinds of polyesters. I just drew a few, but you could have billions of iterations of polyesters. Does that make sense? You can have any combination of a polyester depending what, between an alcohol functional group and an acid functional group, you could have anything in the middle, and technically that would be a polyester, right? So that polyester isn't just a piece of cloth, it could be anything, right? No problem, Rida. Does that make sense? Do you guys agree? Thumbs up if you guys agree. Polyester could be anything, and depending on what molecules you're using, between it and what carbon, what the combination is, it'll show you different properties. Now the one polyester you use, so there are many different kinds of polyesters. Technically polyesters could be natural or they could be man-made, synthetic. Man-made or synthetic mean the same thing. Okay. Now there's one polyester called Tereline. Now Tereline is the actual name of the polyester that we used to wear. It's in clothes, bags are made out of it, your Nike track pants are made out of it, you know, that plasticky fabric, that's polyester. But sir, I've never worn a shirt that's plasticky. Is someone's going to ask that, right? I've never worn a shirt that's plasticky. And that's true, because that's half polyester. What happens is they use a thread of polyester and they weave cotton all around it, right? So that cloth feels very different from your regular cotton. It seems a bit more plasticky, but otherwise, so what it does is, this won't break because this is technically a fish line sort of material, very thin going through the material, and outside is cotton. So it's okay when you kind of like wear it, it feels fine, and it has strength. The polyester gives it strength, right? because it's a very tough material. So that's how you use it when it comes to shirts. Sometimes it's a 70% cotton, 50% cotton, 20% cotton. And the lower the amount of cotton, the lower the, the higher the polyester amount. Does that make sense? Do you guys? So that material for clothes and everything is actually Tereline. Tereline is a type of polyester which we wear. This is the polyester which we wear. Okay, you guys get it? Good. Now the issue is we're used to calling that material polyester. We call it either polyester because branding, right? Or we call it parachute wala kapda, parachute cloth, right? That's how we know it as. But over here we call it gas, petrol, and in the US they call it either gas or gasoline. So it's the same thing. The naming is different because they just liked calling something in one particular way, right? So our examiners call the same material Tereline, which we call polyester. Tereline is one kind of polyester, right? And Tereline is specifically the material you wear or you use as fabrics. Does that make sense? Spam salute if you agree. Why am I talking about so much about Tereline is they'll ask you either Tereline is a synthetic material, give one use of it, and you'll say clothes or parachutes. They'll ask you, Miral had a really bad accident. Sorry to hear that, Miral. I hope you get better. Yeah, so they'll say, and you just talk about the same polyester you know and love, but know that they're calling it Tereline. And so here's your polymers, and there are many kinds of polymers. You have your addition polymers and your condensation polymers. उनमें से एक polymer condensation type होता है polyester. उसमें से एक particular polyester is a Tereline. It's called Tereline, and that's the one they keep talking about over and over again. They won't shut up about it. You'll see, you probably saw 1 or 2 Tereline questions. I'll actually show you what Tereline looks like, how they make it. Actually, the Tereline molecule is too complicated to make, so this is how the book is showing it. And I'll show that to you. Oops. Okay, let's paste it here. These are the 2 monomers of Tereline. And you could look at it and go, hey, this is a polyester. This is going to form polyester because here are my 2 acids, here are my 2 alcohols, right? And they'll join in together to form it, right? And they will, you're absolutely right. And even the book shows it. But what the book does is they try to simplify it and they only focus on the functional groups. And they're only showing it just because of, so you guys have an idea. But you don't need to know this. You just need to know what Tereline is and some of its uses, like clothes. So what the book right now is doing, I have the book open in front of me. What the book is doing is taking all of this and putting it as a red rectangle. Right? They're using a red rectangle to simplify it because the molecule polymerized would look really weird. And for the alcohol over here, they're putting a orange rectangle, and I'll show you how they're showing it polymerized, and it's exactly the same. Exactly the same. Is it the same? Exactly the same? Yeah, exactly the same. This is how the book shows it. So you saw it, and us do the same thing. So this is the same molecule over here as the red rectangle, and they're not hiding the functional groups, they're emphasizing the functional groups. And over here the alcohol is the same, and look what they're showing, the OH and the OH. The acid is losing the OH, but the alcohol's OH is just losing an H, and they form water. This is important, right? And you know why it's important. And they bond together like that, and they just showed an ester over here, right? And in the next picture they're showing how this particular ester can undergo more esterification, more condensation, and polymerize even more. and I'll put that here. Lego pieces. Yeah. Do you guys get it? It's the same process. They showed Tereline as an example, but look how they simplified it. Once you know polymers and polymerization of these things, it's very easy. Does that make sense? Yeah. Okay. ठीक है. Okay. Now this is probably the most rata thing I'm gonna ask you to do, but I think it's important if you do it. These are the polymers they'll keep mentioning over and over again. You guys should know what it is. You don't need to know anything about it aside from where they use it. Right? Some like Tereline they'll keep asking you about over and over, but we went over it in slight detail. Here are some of the polymers we go over, and some of the polymers which we'll do even, but I think it'll give you confidence if you have this written down somewhere, and when you're doing questions you can always use this. I would strongly recommend, we don't have too much time, I don't think there's another class. I'll ask Sir Bilal, but write this down. Please write this down. I'll ask Sir Bilal when he wants me to end class. Write this down. Make this table. Please write this down, and we'll go over it. Oh, you did it? What? How are you so fast? Oh, you took a screenshot. I would strongly recommend write this down. I'm also going to talk about it once more. Leave some room because we're going to try and draw some molecules right next to it. No, I know. You don't have to write all the examples. Maybe write 2 for each. Let me try highlighting. You can say plastic bags, gloves, it's the same plastic, bowls, chairs, and dustbins, water pipes, hoses, covering for electricity. I don't really like the Wellington thing. That's silly. Crates and ropes. Polystyrene is just packaging. Insulation for roofs. Teflon coating for frying pans. Non-stick. Fabric protector, sure. Nylon or ropes, fishnets, and lines. Clothing, Tereline, right? You saw that. We talked about it. We'll talk about it. Just write this down once. We'll talk about it. This is so annoyingly green. What's wrong? Is something wrong with my screen? I think it is. There is something wrong with my screen. All right. How short are we from Mesam? It's really good if you, I'm giving you time. Okay, fine. You guys can write it tomorrow because it's a video, right? Hi, guys. Hi, Samir. How are you? 8 likes. We're 87 short from 95 likes, our goal for today. Okay. So polythene, the structure of polythene is, if you have a screenshot, I'll just do it there because the green is really annoying me. I don't know how you guys are seeing it. On my end, it's just really bad. Polythene is just many ethene, right? This is what it looks like. Right? Polythene. Then it's polychloroethene. What does polychloroethene look like? Kind of forgot. Not that you need to know this. Again, I do emphasize that. It's just that it's good to know because you understand what they're talking about. Polychloroethene. That's what it said, right? And it's a polymer like this. Is exactly like ethene, but it has one Cl. PVC, polyvinyl chloride. If you don't know this at all, that's completely fine. You don't have to draw the structure or anything, but it's good to know, I guess, because they'll just sometimes talk about it. Right? What happens with polychloroethene is, you've seen this a lot. You know those plastic pipes you have around the house where water is going through? Or, yeah, I'll talk about Wellington. They make it out of this. So it's plastic. The chlorine is very similar to polyethene, but the chlorine makes it slightly stronger, I guess. So they use it for pipes. It's called vinyl as well because it's the same vinyl you use to make vinyl records. It's the same plastic. So those big black discs that go on gramophones, I think they're called gramophones, those audio records. Same material. That's why it's also called vinyl. Yeah. Right? Wellington are your, like it's a plastic. It's Wellington boots are your, those big boots you wear for the rain, the really waterproof ones, the high knees sort of ones. Those are Wellington. So that's what they're talking about. That material is that. Okay. So it's not too important. It's just like some form of plastic, right? Pipes is a good enough example. Don't worry yourself about Wellingtons. Okay. Then we have tetrafluoroethylene. And you can probably understand what that means if you know what tetra means. Tetra means 4. So it's saying tetrafluoroethylene. And they're trying to say it's an ethene molecule with 4 fluorines. So that's all the hydrogens technically replaced with fluorines. So this is what fluorine tetrafluoroethene looks like. Right? And fluorine, once it's bonded, it doesn't really like to share electrons, and it holds its electrons really close to itself, and that results in very little intermolecular force from anything else. So this makes it a very good non-stick surface. So you apply this coating of tetrafluoroethene, or the generic, the commercial name for this is Teflon. And you wrote about Teflon. Teflon is the same material, tetrafluoroethene, this molecule over here, that you use to coat frying pans with, so they become non-stick frying pans. Does that make sense? And it's all because of fluorine, right? Prevents other things from, very interesting. It has you can almost say it doesn't have intermolecular forces. So anything that burns doesn't stick to it, or anything on it doesn't stick to it, doesn't get close enough to kind of form that kind of stick. I don't know how something when burned sticks to it. I don't think it's a chemical reaction, but yeah. Okay. And that's the idea. So Teflon, tetrafluoroethene or Teflon. You also use it to coat irons with it. So when your iron becomes too hot and if it's burning your cloth, it'll burn it, but it won't stick to it. So any new iron would have that coating on it. And I think anything else that they specifically want things not to stick to will have this Teflon coating. Okay. Then we have polystyrene, which I won't bother drawing. Okay, maybe I should. Polystyrene. Polystyrene, you guys know what polystyrene is? Is that white, thick, white, soft stuff? Polystyrene, I don't know how to spell. Polystyrene. And this is what it looks like. Again, you won't even understand what it looks like because we haven't really studied that part, or we don't even study it. This looks really ugly. Why am I doing such a bad job drawing these? I'm tired, that's why. Long day, long day. So it just has a C6H5, and sometimes you'll see the C6H5. It's a weird thing. They won't ask you anything about it. You see it. If you have to copy it, just copy it. Sometimes you see this C6H5. It's called a phenyl. C6H5. You can Google it, what it looks like, but we don't need to worry about it at all. C6H5. And the bottom side are all H's. Again, you don't need to know this. And this is your styrofoam, right? Or thermopore or whatever. It's that really soft material. Your coffee mugs, if you get coffee, the plastic ones, they're made of these because they're very good at insulating the foam thing and the white thing, right? So it's also this. So it's also a really good insulator of heat. I don't know why, but it does it. And that's why you put coffee in it. It's also really cheap, as most organic stuff are. So you put coffee in it and you drink it, then you throw it away. So, have you guys ever heard how the petrochemical industry is supplying supporting like plastics, and a lot of other chemicals are rubber and whatnot are considered petrochemical products, or like products from the petrochemical industry? You can understand why, because all these polymers are generally plastic, rubber, Teflon, polystyrene. All of these things are petrol products. So it's not just fuel we use all that crude oil for. We use it for many things. You look around you, there's probably more petroleum-based stuff around you than you realize. All plastics are organic or, petrochemical based. So everything around you is plastic, isn't it? I have so much plastic around me. Then you have rubber. Then you have some paint, which are oil-based, which are all petrochemical. Oil-based paints, right? Oil. Anything to do with oil is more likely either coming from food or petrol. Spirits, thinners, and nail polish removers are all petrochemical based as well. Are you guys like blown out of your mind how important petrochemical is? If you're a chemical engineer, and if you take the highest paid chemical engineer is in the petrochemical industry, because it's the most important, most what's the word? Lucrative, most that's where people are required a lot, because that's where we use it. Yeah, petrol is no joke. Your crude oil, that's why people can't stop drilling for oil, because it's so freaking useful to have cheap things lying around that do not, that's why it's also so much of a waste and such a harsh impact on the environment. Your shoes are made of these things. Half your clothes are made of these things. Your glasses, your watches. It's so common. That's why it's such a thing. That's why they tell you to buy in fashion where it's responsible, right? Don't buy plastic bags. Buy paper bags. They'll decompose. If you buy plastic bags, these things do not decompose. They'll stay there and destroy the environment. By destroying the environment, they just do not degrade over time. They just stay like that. And eventually someone or something is going to touch it or end up eating it and be poisoned by it, or have a bad time, or it gets stuck in animals, while they're breathing, especially in the ocean. It gets stuck in their mouth, or it fills up their stomach, and over time they can't process food and they die. And this is happening a lot. Although plastic bags have been banned, many shops still sell it. Yeah. Microplastics, not too sure what that is. Yeah, microplastics in your, I've heard of this, microplastic in your exfoliating face washes, right? Plastic beads, is that what you're saying? That was specifically poisoning people. So if you guys don't know, face washes have tiny little beads. So when you clean your face with it, the beads are tiny abrasives that kind of take your skin off, and that's a good thing. Like the dead skin on the surface, it takes it off and cleans it really well. So it's kind of like a scrub. Instead of actually rubbing your face with like Scotch-Brite, you're using that, and it's gentle enough. because they were plastic made, and when you would wash it, all of that would go into the drain and end up in the ocean. Those plastics, a lot of animals would end up eating it. And it's not only done when someone eats it, because what happens to fish when they eat it and die? Some other fish or bacteria will eat them, and something else will eat them. So things kept eating those and kept dying over and over again, and that poison, so to speak, poison plastic keeps killing them, and it'll keep on killing things even if you stop throwing it. It'll keep on killing until it's there, until someone goes down there and filters it all out, and no one's going to do that because it's too much work. It will, for the next million years, keep killing those animals because it's just there. And they don't know. It's going to get in their eyes, their mouth, their food, everywhere. So pollution by plastics and petrol, and that's just plastic pollution. Anyway, enough of this talk. Do you guys get this? Polystyrene, we're done. Did we leave any particular kind of... yeah, we left one, nylon. Maybe we can look at nylon right now. ठीक है. Let's do one or two more questions before we move on to nylon. Sorry, I should have warned, but at this point, very similar question. This is an interesting question. Try this. I like this question. So, like when you're buying something, you should be responsible about it. Not just the plastic or the pollution aspect of it, how much money it costs. Is it really good for you? Because with what's happened is, we don't realize this, but the last 50, 60 years, people don't buy things anymore because they need it. They buy it because they're told to buy it, because marketing plays a large role in telling you what you have to buy. And marketing is so successful because it works. People buy things because they don't need all the time. Like sugar things, candy and whatnot, is incredibly bad for you in the long run. But people buy it because, people buy McDonald's. It's bad for you, but people keep buying it over and over again because they're addicted. It has sugar in it. It's addictive. So all this talk about pollution is not about you, I don't know, like, it's not about look at this modern tragedy. It's about raising awareness. That's where chemistry or any science fails to do, the human aspect of it. Is to raise awareness so you guys become more responsible buyers. Because end of the day, if everyone buys an electric car, I'm not saying go buy an electric car right now, but everyone stops wasting fuel, and everyone starts buying things that have plastic, if they only buy plastics if they need it, rather than plastic bags. They buy chips and throw the plastic away. If you stop doing that, chips are already bad for you anyway. So if you stop doing that, the environment will get better. But everyone has to get together and do it. Put a stop to this. So people stop selling us things in plastic bags. That's the idea. But let's do this question. Thank you for coming for my TED Talk. I hope you guys enjoyed and learned something out of it. Lol. All right, should we end the class soon? I think we should. Let's just do this question and end the class. And we'll continue tomorrow with nylon. Okay. This molecule can undergo two different kinds of polymerization. Name these two types of polymerization. I think the question is easier because there are only two types of polymerization we've done: addition and condensation. And coincidentally, this molecule can undergo both types of polymerization, right? And you guys see that. There's addition polymerization and there's condensation polymerization. right? And you guys see why. Either the double bond can break, or this molecule can react with itself. The alcohol can react with the acid from a different molecule. And let's see how it does it. So if it's addition, this is what it's going to look like. For addition, you will have this molecule open up the this is incorrect how I'm drawing it. The carbon has to be matched with the bond, the OH. This turns into, I'm just showing the entire thing. You just have to draw the final product. I'm drawing the whole thing so it's easier for you guys to process it. Right? It is a bit crowded down there. Right? And how it can undergo condensation polymerization is like this. You have to draw either of the ones. Condensation, polymerization. And this is going to be the same molecule. I'll just draw the product. Is going to be O bonded O C. It's not coming out in a nice line, so I'll cheat that way. O C double bond C double O, like that. C double bond O. And it's probably difficult for you to see this. I have rearranged the molecules significantly to make my life easier to draw this. I hope you guys can appreciate that. Right? I'll erase this and I'll start adding the missing hydrogen. And I think I'm done. Does this make sense? Do you guys understand the two polymers I've drawn in each case? So either I've opened up the double bond and polymerized it like so. This is very straightforward to get. This thing, just one less double bond, open it, copy paste this thing over and over again. This is probably tricky to understand, and I won't explain it in detail. You guys try doing this with this in mind, and if you can't get it, we'll continue explaining this tomorrow. But I think once you draw it, it should be straightforward. Does this make sense? Momin, thank you so much for acknowledging our efforts. Words like these just make us go, you know, do more. Just a little thank you every day. Just no one realizes this, but thank you so much for saying it. I hope you do well. Thank you guys. Bye-bye. Bye Mesem, bye Miral, bye Rida. My salutes to you as well. Take care. Allah Hafiz. Allah Hafiz. Bye YouTube. If you have any questions, please post in the comments. If you like the video, please post it in the comments. Bye bye. Take care. Have a great night.